amazing life of mammals. Today we'll be speaking about a very eccentric group of flying mammals, everybody's favourite, the bats. Being the most diverse group of mammals, bats have an incredibly highly variable cranial structure. It's important to note that different muscle groups impact the gape and the force differently. Bats are very important to our ecosystem. Jaw musculature is not a very well-known portion of the bats, but it is very important. Their diet is highly dependent upon what they can bite and what they can fit in their mouths. Harder prey requires a higher bite force and a different structure of the muscles. Others, such as fruit-eating bats, need more mastication. Bite force of these bats. We've created a static bite force model based on the size and orientation of these muscles as well as the gape. We evaluated many different morphological traits and cranial lengths to better understand and scale it between the species. In bats, one would expect the evolution towards high bite force to be associated predominantly with an increase in the cross-sectional area of the M. temporalis. Let's see if we can go take a look. If luck prevails, bats will be on our side. Essential to the bite force and gape of these bats are the M. temporalis and M. masseter muscles. Let's see how this works out.
Hello, and welcome to my lab, where today we'll be looking at 24 different species of bats which have been dried in ethanol for some period of time. Particularly, we're going to be looking at the bite force and gape size of these and how it changes with different size. To create our 3D model, we need the origin and insertion places of the jaw muscles of the bats. To create our model, we needed to dissect each of the bats, measure the length of the different muscles in the jaw, and to take pictures, like so. Now, with these pictures, we were able to create our 3D model, which compared the different muscle lengths and how that contributed to the bite force of the bat. The bite forces calculated with our models and the bite forces from the in vivo samples were correlated to make sure our model was used correctly. And now, we would like to take you to our results. After the study, calculated and measured bite forces had strong correlation showing the accuracy of the models used to determine bite force. From the study, it was determined that larger bats have a longer muscle fibers, a greater cross-sectional area, and larger jaw muscles. Therefore, the larger the bat, the greater the bite force.
Bite force and gape are highly dependent upon the muscles that these bats have and how the length and orientation of these muscles. Smaller bats generally have looser muscles and a smaller gape, illustrated by this. Taking small prey. Larger bats with tighter muscles and larger gapes have bites much like this. We've come to this dark and disgusting cave in the hopes that with a little bit of luck we'll come across some of these amazing creatures. And here hangs the bat, majestic and beautiful. We better get out of here before it wakes.
Overall, our bite force model turned out to be a pretty good predictor of in vivo bite force. While the model allowed for the assessment of animals that you could not collect in the wild, there was a slight tendency for the model to underpredict the bite force of larger animals. Results showed that short fiber length, large cranium, and a large M. temporalis tended to be the largest bite force. Therefore, animals that may have evolved a higher bite force may be restricted to eating smaller prey due to their short fiber lengths between their muscles.
The increase in the bite force of these bats has come about due to a change in the orientation and a shortening in the length of the muscle fibers, not on an increase in the mass of the muscles themselves. This has changed the gape as well as the force and become a very important portion of the bat's jaw. And so concludes our research into the bite force of bats. Thank you very much for joining us, and I hope you come back to watch The Life of Mammals. When did you sleep?
Oh, well, it's funny you should mention that too, because I can't sleep during the night. I don't know what it is. I just can't do it. So I get most of my sleep during the day.
Great, great. Well, you mentioned eating. How does your mouth and how does that work?
Oh, well, it's funny you should mention that as well, because the cross-sectional area of the M. temporalis, when it's increased, it increases the bite gape, and that causes me to have a outstanding bite down onto things such as apples.
Great, great, great. Thank you very much.